Okay, ma'am. So the next topic which we are studying is Calorimetrima. What is meant by calorimetry? Transfer of heat energy from hotter body to colder body. That science is called as calorimetry. Clear, no? So heat always travels from which body to which body, ma? Hotter body to colder body. So for example, this is a body at higher temperature, at a temperature of T1, and this is a body of temperature T2. So, and we are connecting them by some rod, or we are placing them together. Then definitely I can say that if T1 is greater than T2, then this is the direction of heat energy. Okay? Heat energy always travels from hotter body to colder body naturally. That is, we need not do anything here. You need not spend any energy. Already we studied this one, no? But if I have to supply heat energy from cooler body to hotter body, then I have to supply heat energy. Understood, Nama? And this transfer of heat energy will continue up to which time? Continuously heat will travel. So Sima, if this body is losing heat energy, temperature of this body reduces, no? And temperature of this body increases. Clear, Nama? So when both bodies attain same temperature, then the transfer of heat energy will stop. Are you able to understand? And that condition is exactly what is called as thermal equilibrium. So what is meant by thermal equilibrium? Thermal equilibrium is a situation where heat energy is not flowing from one body to another body. It means both the bodies, they should be at same temperature. That is called as thermal equilibrium. Okay, so write down. So a condition when heat energy does not flow from one body to another. Is called thermal equilibrium. Okay, ma? And at a thermal equilibrium, what about the temperatures, ma? At thermal equilibrium, temperatures of bodies will be constant, or you can say will be same. Temperatures will be same. That condition is called as the condition of thermal equilibrium. Understood, Nama? When temperatures, if they are constant, then you cannot expect heat energy to flow, no? Heat always flows from hotter body to colder body. But both of them, if they are at same temperature, then no transfer of heat energy. Clear? Similarly, I will write one misconception, ma. Try to understand this one. See, ma. So this is one misconception generally where students get confused, ma. So see here. So if temperature of a body is greater, then its heat energy is also greater. This statement, is it correct or not? Temperature of the body, if it is greater, the amount of heat energy contained in this body is also greater. Is it correct? Sure. ఆలోచించండి, మట్టి కాకుండా కొంచెం బుర్రతో ఆలోచించండి. Okay? So I am saying that it is a misconception. It means it is not correct. What is the misconception I am saying? If temperature of a body is greater, does it mean that heat energy in that body is also greater or not? Sima, for example, I take 1 kg body, okay, or any metal you take, 1 kg iron you take, and here you take 10 kg iron. Are you able to understand? So both are iron metal I am taking. So I am heating them. Okay. So I am heating them with the same type of lamp. The type of lamp is same type of lamp. So therefore this one I will heat for 10 minutes and this one I will heat for 10 minutes. Are you able to understand? Both of them I am heating for same time. It means that I have supplied same amount of heat energy, no? So here also I have supplied same amount of heat energy. Here also I have supplied same amount of heat energy. So here Q1 is the amount of heat energy. Here Q2 is the amount of heat energy. Definitely I can say Q1 and Q2 both are, they are same. So final temperature of this body will be how much? Initial temperature, let it be 20 degrees Celsius, and this was also at 20 degrees Celsius initial. Final temperature of this body, let us say it is 120 degrees Celsius, for example. Okay, ma? Then what will be the final temperature of this body? Less than 120, greater than 120, or equal to 120? Definitely 120. This is a 10 kg body, no? So its rise of temperature will be only 40 degrees Celsius, for example. Are you able to understand? Approximately I am saying. Understood, no? Why? What is the difference here? Mass of the body is very big, no? Ma? So if mass of the body is very big, rise of temperature will be very small. Okay? This is a very small body, only 1 kg body. But you are supplying huge amount of heat energy, no? So rise of temperature also will be greater. Are you able to understand? So same amount of heat energy if you supply, you cannot expect that much amount of rise in temperature. Because this is a 1 kg body, this is a 10 kg body. So 10 kg body mass is bigger, no? So to rise its temperature, we need huge amount of heat energy. But we are supplying same amount of heat energy. Are you able to understand? So what is the final temperature of this body? Final temperature is 120. Final temperature of this body is 40. So which body is at a lower temperature? This is at a lower temperature. And this is at a higher temperature. So does it mean that this body is having higher heat energy? This body is not having higher heat energy. We are supplying same amount of heat energy. Are you able to understand? Temperature is lesser. It doesn't mean that its amount of heat energy is lesser. Are you able to understand? And to take this 10 kg body to 120, how much energy I have to supply? Very huge amount of energy I have to supply. I have to heat this one nearly for 1 hour. Are you able to understand? I have to heat this one only for 10 minutes. But this body I have to heat for 1 hour. Are you able to understand? Then it goes to a temperature of 120 degrees Celsius. So it means now temperatures are same, no? But to which body we are supplying more amount of heat energy? To the second body we are supplying more amount of heat energy. Temperatures are same, no? But heat energy supplied is not same. Are you able to understand? So definitely this is a misconception. So if temperature of a body is greater, then it doesn't mean that heat energy is also greater. Temperature is a different thing, heat energy is a different thing. Are you able to understand? Make a note of that example here. Okay, ma? So the next concept which we have to study is specific heat capacity. Ma? In total this chapter of thermal properties, this is the most important concept. Specific heat capacity. Clear, ma? Now see. So the amount of heat energy supplied, the amount of heat energy supplied is called Q. Okay, ma? And Q is directly proportional to mass of the body. Just now we have studied, no? If I want to raise the temperature of 10 kg body to 120, I have to supply very huge amount of energy. Okay? So the amount of heat energy supplied is directly proportional to what? Mass of the body. If mass is greater, you have to supply more amount of heat energy. Okay, ma? This we don't know. Practically in real life also you should have seen, no, ma? So if you want to cook this much of rice, you can cook in 5 minutes. If you want to cook 10 kg or 20, 100 kg of rice, it takes a very long time. Clear, no? So Q is directly proportional to mass of the body. M means mass here. And Q is also directly proportional to delta T, change in temperature. Again, same example you can take, no? To heat from 20 to 40, you require only 10 minutes. But to heat from 20 to 120, you require 1 hour of time. Are you able to understand, ma? So to rise the temperature also, and what is the rise in temperature? Hath kado jesu bara. Chetul diyandi gaddal kinda panukuntana ya sari kuchondi. Clear, ma? So amount of heat energy supplied is directly proportional to rise in temperature. If you want to rise the temperature by greater value, you have to supply more amount of heat energy. So if you combine both of them, then what I can write? I can write Q is directly proportional to M delta T. This is what you can write. Okay? So Q is proportional to mass also, Q is proportional to change in temperature also. Now if I want to remove this proportionality, these two factors, no, ma? So if you combine them, then I will get Q is proportional to M delta T. Now if I want to remove this proportionality symbol, I have to place a constant, no? Clear, no, ma? And that constant is nothing but S. So Sm delta T. Clear? Where this S is called as specific heat. Okay, ma? Specific heat. So how can I define this specific heat? Let us see. So therefore I can write S is equals to Q by M delta T. This is what I can write, Nama. Clear? Now by looking at this equation, can you say what is the definition of specific heat, ma? By looking at the equation, what is the definition of specific heat? Amount of heat required per mass per rise in temperature. You have studied the definition. Formula chadivi vinipinchunaru naaku. What is the meaning of that? What do you understand by this relation? The amount of heat required to rise the temperature of 1 kg body by 1 degree rise in Celsius. That is called as specific heat. If I want to write in SI system, everything I have to measure in terms of SI system only, no ma? Okay. So therefore, how can I measure this one? The amount of heat energy required to rise the temperature of unit mass of a body, or you can say 1 kg body in SI system. By how much rise in temperature? 1 degree rise in temperature. So you are taking 1 kg body and you want to rise the temperature by 1 degree Celsius. Then how much heat energy you have to supply? That is called as specific heat. Are you able to understand? And specific heat depends on what? It depends on nature of the material. Are you able to understand, ma? Specific heat is not same for every material. For example, if you put a hot food in aluminum plate and same hot food if you place on a stone, so both of them, will they get heated up to same temperature? If you place hot food in aluminum plate, it gets heated up very fast, no? You cannot hold that plate. But same hot food if you place on any stone or other material, you can hold it very easily. For example, if you plate a hot food in a steel plate, it is not a problem for you to hold that one. Are you able to understand? It means the rise in temperature is not the same for every body. It changes from body to body. So let us first write the definition of this one. So what we write, specific heat is, specific heat is the amount of heat energy required, amount of heat energy required, okay ma, to raise the temperature of unit mass of a body by unit rise in temperature. Okay, ma? That is called as specific heat. Understood, no? So what can be the units of this one, ma? So S is equals to Q by M delta T, no? Q nothing but joules in SI system. Amount of heat energy is represented in joules. Per mass it is represented in kgs. Delta T it is represented in Celsius or Kelvin, both are same. Because we are studying about a change in temperature, no ma? Change means you can write Celsius also, you can write Kelvin also, because change remains the same in Celsius scale as well as Kelvin scale. So you can write like this also. Okay, ma? So now, for example, let us write one example. Specific heat of water is equal to 4200 joules per kg Kelvin. Specific heat of metal, lead metal, it is equal to 130 joules per kg Kelvin. Okay. So if you look at this two data, what do you understand? If you observe this data, what do you understand? LKG student also can say that. This is 4200, this is 130. What do you understand? That is important. Is greater than specific heat of lead. Wow. Oh, still what do you understand? See the definition what we have written. ఒకసారి చదివితే అప్లై చేసేసేయాలి మీరు. దీనికని ఇది ఎక్కువ నాది లేదు, ఇది ఎక్కువనే. ఇంకా దాని తర్వాత ఏందో చెప్పండి. Sima, if I take 1 kg of water, here I have written kg, no? It means I will take 1 kg of water. I will rise its temperature by 1 degree Celsius. So initially let us consider water is at a temperature of 30 degrees Celsius. Lead metal is also at a temperature of 30 degrees Celsius. Understood, no? How much amount of water I am taking? 1 kg of water. How much amount of lead metal I am taking? 1 kg of lead metal I am taking. And I want to raise the temperature from 30 to 31 degrees Celsius. Water. Lead also I want to change from 30 to 31 degrees Celsius. What is the rise in temperature? 1 degree Celsius or 1 degree Kelvin. That is the rise in temperature. Then in that condition, masses are also same. No, this is also 1 kg, this is also 1 kg. Change in temperature is also same. But to raise the temperature by 1 degree Celsius to water, I have to supply 4,200 joules of energy. 4,200, it is nothing but unit of energy, no? How much energy I have to supply? 4,200 joules I have to supply. But in the case of lead, it is enough if you supply 130 joules of energy. That is the meaning of it. Okay, ma? If you just supply 130 joules, temperature of lead rises by 1 degree. Same mass. Mass is 1 kg only. Okay, but to raise the temperature of water, I have to supply very, very huge amount of energy. Okay, many, many times huge energy I have to supply. So what do you understand? We understand that specific heat of water is greater. It means that for same rise in temperature, I have to supply more amount of heat energy. Okay, mass is how much? 1 kg, 1 kg. Change in temperature is how much? 1 degree, 1 degree. But here I have how much energy? Only 130 joules. Here I am supplying 4,200. So it means that water doesn't get heated up very fast. Water anta twaraga heat avvadu. Though you are supplying heat energy, its temperature will not rise by great value. That is why water is called as a natural coolant. Clear? Water is called what? It is called a natural coolant. Okay? So in our cars also we pour water, no? Why pour water? కార్కి ఏమన్నా దప్పికి వేస్తుందని వేస్తామా? ఎందుకు వేస్తాం వాటర్? లేకపోతే అదేమన్నా కూల్ డ్రింకులు తాగుతుందా? ఈసారి థమ్స్అప్ బాటిల్ వేయండి. Why we pour water in car engine? What is the reason? Because water is a very good coolant. Why it is a very good coolant? Because its specific heat is very large. So it takes a huge amount of water from the car engine, but still its temperature will not rise by greater value. Okay, ma? So specific heat depends on what? Depends on nature of the material. Are you able to understand, ma? It changes from material to material. That is the meaning of it. So therefore, what is the note point we have to write here? Note point is that if specific heat is greater, okay, ma? So if specific heat is greater, then what is the meaning of this one? Then it means that material's temperature does not rise very fast. Clear, no? So specific heat, if it is greater, it means that even though you supply huge amount of energy, its temperature will not rise. It is taking energy, but still its temperature will not rise. That is called as specific heat. Are you able to understand, ma? Okay. And one more note point is that, okay, ma? Specific heat is mentioned for unit mass. Okay. So specific heat remains the same. Specific heat remains the same for 1 kg or 10 kg body. Okay, ma? Specific means what? For 1 kg. Specifically we are taking, no? Or in CGS system for 1 gram of a body. So therefore specific heat is always a constant for a particular material. For 1 kg body also specific heat is same. For a 10 kg body, 20, 30 kg body also specific heat remains to be same, because it is specific. Specific means what? Already we have taken per kg. Per kg we have taken, no? So it is always a constant. For 1 kg iron also it is same. 10 kg iron also it is same. 100 kg iron also it is same. Because it is not dependent on mass. Specific heat is not dependent on mass. Because already we have taken per kg, no ma? So for 10 kg body, for 100 kg, 1000 kg, body is same. specific heat also will be same. So therefore what we write, it is independent of mass of the body. Another note point is that it is independent of mass of a body. Okay, ma? It doesn't depend upon mass of the body. Similarly, one more parameter we will study, which is called as heat capacity. Okay, ma? Next parameter is heat capacity. Okay, ma? So what is meant by heat capacity? The amount of heat energy required. The amount of heat energy required to raise the temperature of total body is called as heat capacity, represented by the letter H. So H is equals to Q by delta T. This is the relation which I have to write. Okay, ma? So Q is equals to H is equals to Q by delta T. Okay. So now can you say what is the difference between specific heat and heat capacity, ma, which is very important? Specific heat is independent of mass, but here kg is there, no? Then how it is independent of mass? Specific heat? Heat capacity is? ఒక్కరు చెప్పండి, వన్ బాడీ ఎవరు చెప్తారు ఫస్ట్ చెప్పరా? So what is the difference between both of them? Are there difference? Okay, still anybody? Here for total body, that's the difference. Clear, ma? See, ma, specific heat is the amount of heat energy required for every 1 kg body. So it is mentioned specifically. So therefore it doesn't depend on total mass of the body. Are you able to understand? Because already we have mentioned it for 1 kg. For 2 kg also same, for 3 kg also same. Because we have mentioned for every 1 kg. But heat capacity is a different concept. See, ma, here in the formula you don't see any mass here. Okay? But specific heat, how we have written specific heat? Specific heat we have written S is equals to Q by M delta T we have written, no? So what is the difference between these two equations? Here mass is present, but still it is independent of mass. Here there is no mass, but it is dependent on mass. How it is dependent? Let us see. Okay, ma? See, what I do is, I will take 2 bodies, ma. I will take 1 kg body or 1 kg iron box I am taking, and 2 kg iron box I am taking. Okay, ma? So its initial temperature is 30 degree. Its initial temperature is also 30 degree. I want to raise its temperature to 31 degrees Celsius. This also I want to raise from 30 to 31 degrees Celsius. Okay. So here I am supplying Q amount of heat energy for 1 kg body. Then here how much energy I have to supply? Here how much energy I have to supply? Total energy. Here I have to supply 2Q amount of heat energy. Double energy I have to supply, no? Why? Because mass is double. So that is called as heat capacity. So heat capacity of this body is Q. Heat capacity of this body is 2Q. Okay? We are not taking on per mass, no? We are taking on total mass. Are you able to understand? But specific heat of iron is yes. Specific heat of this iron is also yes only. Are you able to understand, ma? Specific heat of 1 kg is yes. Specific heat of 2 kg also yes only. Because there we are mentioning per kg. What is the amount of energy required to heat? 1 kg of body is called specific heat. 2 kg body specific heat. 3 kg also same. Understood, no? But if you take total body, you have to supply more energy, no? So that total energy is called as heat capacity. Are you able to understand, no, ma? So in specific heat, in formula you have mass, ma. Okay? But specific heat is independent of mass. Are you able to understand? And in heat capacity, you don't find any mass. But it is dependent on mass. If size of the body, mass of the body increases, heat capacity also increases. Are you able to understand? But specific heat, it doesn't depend on mass of the body. That is the difference. Okay? So right now. So here also we will write some note points. So what are the note points we have to write? First point is that if mass increases, heat capacity also increases. Heat capacity also increases. Okay, ma? But specific heat remains same. But specific heat remains same. Okay, ma? So let us try to understand this one by taking one example, ma. Okay? For example, let us take Hindi, English, Telugu, social. Okay, ma? In every subject, you want to score 10 marks extra. Okay, ma? In every subject, you need to score 10 marks extra. Then in English also, you should score 10 marks only. Telugu also 10 marks extra. Social also 10 marks extra. Are you able to understand? But if number of subjects increases, for example, physics and chemistry, number of subjects increases. But for every subject, this remains the same only, no, ma? For every subject, the amount of marks you have to raise is same. But as number of subjects increases, total rise in marks will increase, no? Okay? For 3 subjects, it is only 30 marks. For 1, 2, 3, 4, 5, 6 subjects, it is 60 marks you are rising. Understood? No? But for each subject, it is 10 only, no? So if you do 10 subjects, 10 tens are 100 marks. Number of subjects increases, total rise in marks increases. But for each subject, 10 marks only. Same concept with the specific heat and heat capacity. Are you able to understand, ma? For every 1 kg, you have to rise, you have to supply 10 joules of heat energy. For every 1 kg. That is called what? That is called specific heat. Understood, no? Now as number of kgs increases, you have to supply more amount of heat energy. That is heat capacity. Understood, no, ma? So that is the difference between specific heat and heat capacity. Now can you say, how can I write a relation between them? How can I write a relation between heat capacity and specific heat? Relation between heat capacity and specific heat. Just derive both of them. H is equals to Q by delta T, no, ma? Okay, unit is joules per Kelvin or joules per degree Celsius. Clear? And specific heat is what? Q by M delta T. So divide both of them. So H by S is equals to Q by delta T divided by Q by M delta T. Clear, no? So Q delta T get cancelled. So mass is in denominator, no, it becomes numerator. So H is equal to M into S. This is the relation. Okay? So specific heat of a body is S. For how much mass? For 2 kg, 3 kg, 4 kg, 5 kg. As mass increases, heat capacity also increases. That's it. Okay? So this is the relation between H and S. Okay? For example, let us write a problem. Okay, ma? So specific heat of a metal, specific heat of a metal is 200 joules per kg Kelvin. Okay, ma? What is the amount of heat energy required? What is the amount of heat energy required? Okay, ma? To heat or to raise the temperature of 10 kg metal by 1 degree Celsius. Ever ready? Palgottestaremra babu. Okay, ma? Do this calculation. Do this calculation, ma? So specific heat of a metal is 200, ma. So what is the amount of energy required to raise the temperature of 10 kg metal by 1 degree Celsius? 2000. Yes, that's it. Have you got 2000 ma? H is equal to M into S, no? What is meant by H? Heat capacity. Heat capacity is nothing but amount of heat energy which you have to supply, no? Clear, no ma? So therefore heat capacity is equal to, what is the mass of the body given? 10 kg body. And for each 1 kg, what is the rise in, what is the specific heat? For every 1 kg, specific heat is nothing but amount of energy required to raise the temperature of 1 kg body by 1 degree rise in Celsius, no? So it is nothing but 200. So therefore how much? 2000 joules per degree Celsius or degree Kelvin. It means to raise the temperature by 1 degree Celsius, you have to supply how much energy? 2000 joules of energy. Okay. Therefore, what is the total energy I have to supply? Now I have calculated only H ma. Q I have not calculated. Q means how much? Q is nothing but 2000. That's all. No? So heat capacity means heat energy per rise in temperature, per degree rise in temperature. Okay. So therefore, what is the total heat energy I have to supply? 2000 joules of heat energy. Okay. If I supply this much energy, then I can raise the temperature of 10 kg metal by 1 degree rise in Celsius. Okay. So let us see this question. Ma? So a geyser heats water flowing at the rate of 3 liters per minute from 27 degrees Celsius to 77 degrees Celsius. Okay, ma? So geyser we know, no? Which heats water when water is connected to this one. So how much water can flow in 1 minute? Ma? 3 liters of water can flow. Okay. So first information which I have to write is clear. 1 liter water is having a mass of 1 kg. This is first point which you should remember. 1 liter water will have how much mass? Ma? 1 kg mass. It is only for water only, but not for other materials. Other materials it may change, but 1 kg, 1 liter of honey, it will be greater than 1 kg. But for water it is 1 kg. Okay, ma? So, and we are raising the temperature from where to where, ma? We are raising the temperature from 27 degrees Celsius to 77 degrees Celsius. So what is the total amount of heat I have to supply? First I have to calculate this one, no? Total amount of heat energy supplied is equal to ms delta T. This is the formula. Clear, no? Mass of water is how much? 3 liters of water is flowing now per minute. So therefore I will calculate Q per M. I will calculate. What is Q per minute? Q per minute means what, ma? In 1 minute, 3 liters of water is flowing, no? So I will also calculate amount of heat energy supplied per minute only. Okay. So therefore how much it will be? So Q by M will be equal to, mass of water is 3 kg because 3 liters, no ma? So 3 kg. Specific heat of water in SI system, or let us do one thing, ma? Here he gave in terms of grams, no? So I will convert kgs into grams. 3 kg means how many grams? 3000 grams. 3 into 10 power 3. Okay. Multiplied by specific heat of water in CGS system is 1. Okay, ma? Specific heat of water in CGS system is how much? 1. Specific heat of water in SI system is 4200. These values you should remember. Okay, ma? In CGS system, 1 gram per 1 calorie per gram Celsius. And in SI system, it is equals to 4200 joules per kg Kelvin. Okay, ma? So we are doing in CGS system grams only, no? So specific heat I will write 1. What is the change in temperature? Change in temperature is 77 minus 27. So do this calculation. So 3000 multiplied by 50. Okay, ma? 5 3s are 15 into 10 power 4 calories per minute. That's all, no? Unit is calories per minute only, no? Because I have calculated Q by M. Heat energy per minute. So heat energy I have taken in calories, no? CGS system. So calories and time taken is seconds or minutes per minute. So calorie per minute. This is what I have calculated. Understood? No? It means this much amount of heat energy I have to supply per minute, so that 3 liters of water get heated from 27 to 77. Up to here it is clear, no? Okay, now see. So actually what he is asking us to kind of calculate by heat of combustion. Rate of combustion he is asking. Rate of combustion means what? Rate of combustion means what? Rate of combustion means how much energy you have to spend, or how much fuel should be spent in particular time. Okay, for example, if it is a gas geyser, how many kgs of gas you have to burn, or how many grams of gas you have to burn. Or if it is an electrical geyser, how much energy you have to spend in 1 second or 1 minute. That is called as rate of combustion. So what is the unit of rate of combustion? Rate of unit of combustion is how much more? So grams per minute. That's all. No? Why I am writing in grams per minute? Rate of combustion means this many grams of fuel should be consumed in how much time? And here total standard is taken as minute, no? So how many grams of fuel I have to burn in 1 minute? Okay? So rate of combustion is nothing but grams per minute in this condition. Okay? That is one data. So this is what I have to calculate. Okay? Now let us see what is the one more data given. Given heat of combustion is. Heat of combustion is how much? Heat of combustion is how much more? It is equals to 4 into 10 power 4 joules per gram. Okay? Now can you say what is meant by heat of combustion? Heat of combustion means? Unit student, what do you understand by units? Per gram. This much energy is released. That is the meaning of this one. No? It means if I burn 1 gram of fuel, for heating anything we require fuel, no? So if I burn 1 gram of fuel, then 4 into 10 power 4 joules of energy is released. That much energy is released. But the problem is value is given in joules, no? But we have calculated in calories. So how to convert joules into calories? So already we know, no, 1 calorie is equals to. First of all, let us see answer is given in terms of what, ma? Answer is given. Okay, no problem. Anything we can do. 1 calorie is equal to 4.2 joules. Therefore, 1 joule is equal to how much? 1 by 4.2 calorie. This value already you know, no? So therefore, what is the heat of combustion? Heat of combustion is how much? 4 into 10 power 4 multiplied by, instead of 1 joule, what I can write, ma? 1 by 4.2 multiplied by, now joules have converted into calories, no? Calories per gram. Now everything is in terms of CGS system. Is it clear? Okay. Now see, so this is the first information I have calculated. I have to supply this much amount of heat energy per minute. So 15 into 10 power 4 calories per minute. Okay. Heat of combustion is also given. Heat of combustion is this many calories per gram. Now I want to calculate rate of combustion. Rate of combustion means what? How many grams of fuel should be burnt in 1 minute? And what is the unit? Grams per minute. Is it clear? Now can you say how can I do the calculation? ఏ రెండింటిని డివైడ్ చేయాలి? So heat of combustion by Q by M or Q by M by heat of combustion? Heat of combustion divided by this one. Then in numerator I will get, in numerator I cannot get grams, no? This is what I want. I want grams per minute. Rate of combustion means what? How many grams I have to burn in 1 minute? I want grams per minute. So shall I divide this one by this one or this one by this one? So total heat I have to supply divided by the amount of heat of combustion. Then I will get grams per minute. Understood, Nama? So here I will do the calculation. Therefore, rate of combustion. Rate of combustion is how much? It is equal to 15 into 10 power 4 calories per minute divided by, okay ma? So 4 into 10 power 4 divided by 4.2 calories per gram. Okay. Then calorie will get cancelled, no ma? Gram goes to the numerator. Okay. So if you do this total calculation, whatever answer you get, okay ma, so here I will write down, so dash grams per minute, and grams per minute is nothing but rate of combustion. That's it. Just do this calculation, that should be my answer. Understood now? So the answer which you should get is 15.75 grams per minute. It means for every minute I have to burn how much fuel ma? 15.75 grams of fuel if I am burning, then I can get these results. I am able to heat 3 kg of water in 1 minute. From which temperature to which temperature? 27 to 77. Okay? That's it. Okay, ma. So the next topic is water equivalent. Ma. You need to understand this one carefully, because in the questions he will be giving like this. Water equivalent of a body is this much. Okay? So if you don't understand the definition, you cannot solve it. See, ma. So the amount of water required to get heated up to same temperature for same supply of heat energy is called as water equivalent. Okay? Let us try to understand by taking an example. See, ma. For example, if I take 1 kg lead, what is the metal I am taking, ma? 1 kg lead I am taking. Okay? So I want to raise this temperature from 30 degrees to 31 degrees Celsius. Then how much heat energy I have to supply? Q is equals to ms delta T. This much amount of energy I have to supply. No? Let us do the calculation. So mass of lead is 1 gram, specific heat of lead is 130, change in temperature is 1 degree Celsius. So what is the heat energy I have to supply? 130, I have taken everything in joules only. No? So 130 joules of heat energy I have to supply. Okay. Now what I do is, so instead of lead, if I take water, same heat energy I have to supply. Same 130 joules only I have to supply. Temperature rise also should be 1 degree only. Then instead of 1 kg lead, how much water I have to take? That is called as water equivalent. Understood, Nama? It means the amount of heat energy supplied is same amount of heat energy. Okay? And what is the rise in temperature? Same rise in temperature. Then instead of 1 kg lead, how much water I have to take? That is called as water equivalent. Understood, no? Let us see. So how can I do SEMA? So same 130 only, no? Same amount of heat energy I have to supply, no? But for water, I will write Ws delta T. This is how I can write now. Ws delta T. Okay? So therefore, if I do this calculation, so W is water equivalent. Water equivalent is how much? 130 divided by water, specific heat of water is how much? Specific heat of water is, sorry ma. So W is equals to 130 divided by S into delta T. This is what I have to write now. So 130 divided by specific heat of water is how much? 4200. Rise in temperature is 1. So lead also I have raised by 1 only, no? Water also I have to rise by 1 only. And here heat energy supplied is 130, no? Here also heat energy supplied is 130 only. So therefore, how much water I have to take, ma? So 130 divided by 420, 4200. So 13 divided by 420 kg of water if I take, that is enough. Understood, no? Lead metal, how much I have to take? Lead metal 1 kg. But water, how much I have to take? Only 13 by 420 kg if I take. Then if you supply 130 joules, temperature rises by 1 degree Celsius. That is called as water equivalent. Are you able to understand? So therefore, equation wise, how can I write? Let us see. So as heat energy supplied is the same. As heat energy supplied is same. Okay, ma? So Q is equals to ms delta T is equal to Ws delta T. Okay, ma? This is material, this is water. This is how I can equate both of them, no? Heat energy supplied is same, both of them. But this is some material, this is water. Okay? Rise in temperature is also should be same. So delta T get cancelled. Okay? Therefore, W, how can I write? W into specific heat of water is equal to M into S into M. This is how I can write. Okay, ma? So therefore W is equal to how much? MSM divided by SW. This is how I can calculate water equivalent of any material. Understood now, ma? Now in CGS system, if I calculate, in CGS system, specific heat of water is how much? 1. In CGS system, specific heat of water is 1 norma. So therefore W water equivalent is how much? M into SW divided by 1. Okay. So therefore it is M into SW grams. So this much amount of water if I take, that is enough. Arthamatunda? What is meant by water equivalent? M into SW divided by SW. S means specific heat of water, no? In CGS system, what is specific heat of water? 1. So it is M into SW. SW means SW, no, SM, no, this one. Sorry. M means material, any material. Okay, ma? So mass is mass of that particular material. SM is specific heat of that particular material. It means instead of that material, I want to express that in terms of water. That is called as water equivalent. Understood, Nama? And latent heat. Okay, ma? So see. So next we are discussing about changes in phases, or you can call it as state change. State change means changing from solid to liquid, liquid to gaseous. This is called as change of state. Okay, ma? See, ma, when a state changes, temperature does not rise. Okay, and state of change, state will change only at a particular temperature. Okay, ma? Only at a particular temperature. So these are two important points which you should always remember, ma. So for example, if you take ice, okay, and temperature of ice is minus 20 degrees Celsius. So if you start heating this ice, will it melt, ma? Temperature of ice is minus 20 degrees Celsius. If you start heating this ice, will it melt immediately or not? No. Why? Because melting will happen only at 0 degrees Celsius. Melting cannot take place at minus 20. That's what we have written. State will change only at a particular temperature, which is called as a fusing point of any material, or you can call it as a melting point of any material. You should have studied melting points and boiling points, no? Only at the temperatures only phases will change. Okay. So first of all, this ice, I have to convert this one into same ice at 0 degrees Celsius. Now it starts melting. Okay, ma? So from minus 20 to 0, temperature raised or temperature decreased? Temperature has risen, no? Minus 20 is a lesser temperature when compared to 0. It means here, definitely I have to supply heat energy. And here what about delta T? Delta T, change in temperature is also rising. It means a change in temperature is present. Okay, ma? Now if I continue heating this ice, then first what happens is, this ice converts into water. Okay, ma? Here melting will start. Okay, so ice at 0, it converts into water. Now can you say what is the temperature of water? Temperature of water remains to be at 0 degrees Celsius. Okay, ma? So even you are heating this ice, temperature does not rise. Are you able to understand? So temperature does not rise at which condition? Temperature does not rise when phase is changing. Solid phase, it is converting into liquid phase. When phases are changing, temperatures will never change. So completely, total ice must be converted into water. Then only temperatures will start rising. Okay? So ice, unless it is completely converted into water, its temperature remains to be at 0. Okay, ma? Now again we are continuing heating this water. Okay? Then what happens? Directly can it convert into steam, ma? No. First of all, what should happen? First of all, it will convert into same water only, but at which temperature? At 100 degrees Celsius. Okay, so here also you are supplying heat energy. Okay, ma? So Q1, Q2, Q3, everywhere you are supplying heat energy. Okay, but here liquid state is remaining to be liquid state. Water is in liquid state, no? Here also it is in liquid state. Okay, so therefore temperature will definitely rise. So temperature increases in this condition. Now after reaching 100, still if I start heating, then what will happen? Then it converts into steam, water vapor. And what is the temperature of steam? Temperature of steam will be 100 only. Are you able to understand, ma? So here also we are supplying heat energy. But what is the change in temperature? Change in temperature is 0. Okay, ma? So here also when it is melting, here change in temperature is 0. Okay. Now steam, if I start heating, again what will happen? I am continuing to heat a steam also. Then what will happen? Now temperature of steam will rise. Again it converts into steam at, for example, 140 degrees Celsius. So here also heat energy is required. But here also temperature will rise. So are you able to understand what is the total process? So in this total process, everywhere we are supplying heat energy. Q1, Q2, Q3, Q4 and Q5. Everywhere we are supplying heat energy. But at some conditions, temperature is not changing. What is that condition? Where temperatures are not changing? When state is changing. State means, see for here, this is solid state. Solid state, when it is converted into liquid state, there is no rise in temperature. Okay, ma? Similarly, liquid state at 100, when it is converting into gaseous state at same 100, then also there is no change in temperature. Understood, ma? So when phase changes or state changes, you don't see any rise in temperature. But it doesn't mean that you are not supplying heat energy. You are supplying heat energy. But still temperature will not rise. So you never understand what is happening to the heat energy. అర్థమవుతుంది కదా? ఐస్ గడ్డను పెట్టి స్టవ్ మీద పెట్టి వేడి చేస్తూనే ఉన్నారు మీరు. ఇనీషియల్ టెంపరేచర్ వాజ్ 0. ఈవెన్ ఆఫ్టర్ 5 minutes ఆల్సో టెంపరేచర్ ఈజ్ 0 ఓన్లీ. నెత్తి బాదుకుంటా ఉన్నాడు ముదస్సిర్, ఏమైపోయిందిరా బాబు నేను సప్లై చేసిన హీట్ ఎనర్జీ అంతా అని. ఓకేమా? సో వాట్ హ్యాపెన్ టు ద టోటల్ ఎనర్జీ? It converted into changing of the phase of the system. Okay, ma? So to change from solid state to liquid state, we require more energy. So that supplied energy is utilized only for changing the state, but temperature never rises. Clear, no ma? So right now. So energy supplied is used for changing phase or for changing state. So temperature does not rise. Understood, Nama? So therefore this heat supplied at phase change is called what? Is called latent heat. Okay, ma? Latent means what? Latent means hidden heat. Okay. So which heat is called latent heat, ma? The energy which you are supplying when phase is changing. That heat we can call it as latent heat. Why it is called as latent heat, ma? Because we are supplying heat energy, but we are not able to understand why temperature is not rising. Okay. So that total energy, it appears as if it is disappearing. So that is why it is called as hidden heat, or you can call it as latent heat. Understood, no? మీరేమో హీట్ సప్లై చేస్తున్నారు, టెంపరేచర్ ఏమో పెరగడం లేదు, దిక్కు తెలియడం లేదు మనకు ఏం జరుగుతుందో. అందుకని దాన్ని లేటెంట్ హీట్ అని అంటాం. క్లియర్ మా? దట్స్ ఇట్. ఓకే. సో హియర్ విచ్ వన్ ఈస్ లేటెంట్ హీట్ మా? Q1, Q2, Q3, Q4 or Q5? Which one is latent heat here? Q2 is latent heat, no? Similarly Q4, Q4 only, no? Q4 is also latent heat. Okay, remaining are general heats which we are supplying. Understood, no? So therefore we write in this diagram only, we will try to understand. Okay, ma? Here Which are the latent heats? Q2 and Q4. Q2 comma Q4, they are called as latent heats. Okay, ma? Therefore, to change temperature, Q is equal to ms delta T. This is the formula which we use. Okay, ma? When temperature is changing, this is the formula which we use. Already we have studied, no? Q is equal to ms delta T. And when temperatures are not changing, when state is changing. When state is changing, then what is the formula we use, ma? Then we use Q is equal to M into L. Okay? L is called latent heat. Okay? Understood, no, ma? So when temperatures are changing, where temperatures are changing? Temperatures are changing at Q1, Q3 and Q5. So here temperatures are changing. So whenever temperature changes, then what is the formula I have to use? ms delta T. And when a state is changing, that is temperatures are not changing, then we have to use the formula Q is equal to M into L, where L is called latent heat. And L value also, it depends on material to material. Are you able to understand, ma? For water it has a different value, for petrol it has a different value, so like that. For every material it has a different value. Understood, no, ma? That's it. Now we will write values for water, ma? Completed now up to here. Shall I rub this? For water, when ice at 0 degrees Celsius, it converts into water at 0 degrees Celsius, then the amount of heat energy which have to supply, it is called MLV fusion. ML fusion. Okay, ma? This is LF is called what? Latent heat of fusion. Latent heat of fusion. And what is its value? It is 80 calories per gram. 80 calories per gram. These are the values for water only. Okay. Now can you say what is meant by 80 calorie per gram? To melt 1 gram of ice. To melt 1 gram of ice. What should be the temperature of ice? 0 only. And it should be converted into 1 gram of water. And temperature of water also should be 0. Then how much heat energy I have to supply? 80 calories of heat energy I have to supply. Just to melt 1 gram of ice at 0. To water only, but still at 0 only. I have to supply this much energy. Okay. Similarly, let us calculate latent heat of vaporization for water. This is in CGS system. You can convert them into SI system only. We know 1 calorie is equal to 4.2 grams, no? 4.2 joules, no? According to that, you can convert into SI system also. Similarly, same water. Now, this is water at 100 degrees Celsius. I am supplying heat energy. Then it is converting into steam, and temperature of steam is also 100 degrees Celsius. Then what is the amount of heat energy I have to supply? MLV. LV means latent heat of vaporization. It is converting into steam, no ma? That is why it is called as LV. Okay? Latent heat of vaporization. Okay? And how much it is? It is 540 calories per gram. Okay, ma? So latent heat of vaporization is very big when compared to latent heat of fusion. Very easily you can melt ice, no? To melt ice it is very easy. But to convert 1 gram of water into steam, it is very tough. You have to supply very huge amount of energy. It means 1 gram of water. At which temperature? At 100. Should be converted into 1 gram of steam, again at 100. Then how much energy you have to supply? 540 calories of energy you have to supply. That is the meaning of this one. Understood, Nama? Now I will give you one question. Try to answer that question. Completed, no? Question is like this. Calculate the amount of energy required to convert 1 gram of ice at minus 20 degrees Celsius to 1 gram of steam at 120 degree Celsius. That is the question. Okay, ma? So specific heat of ice is 1/2 calorie per gram Celsius. Specific heat of water is 1 calorie per gram Celsius. Specific heat of steam is also 1 calorie per gram Celsius. These are the values which are given. So see how you can do this calculation. Okay, ma? Okay, ma? So see this calculation. So calculate the amount of energy required to convert 1 gram of ice at minus 20 to 1 gram of steam at 120. Okay, ma? So let us draw the block diagram which we have drawn previously, ma. First of all, what I am taking 1 gram ice. Clear, no? What is the temperature? Minus 20. Now I am heating this one. I am supplying Q1 amount of heat energy. Then first of all, it should convert into what? It should convert into 1 gram ice only, no? But temperature should be 0 degrees Celsius. So from minus 20 to 0, state is not changing, no? Ice is remaining to be ice only. Okay? And Q1 value, what is the formula? Q1 is equal to ms delta T. Why I have to use ms delta T? Because temperature is changing, no? So mass is how much? 1. Specific heat is 1. Change in temperature is how much? 20. Specific heat of ice 1/2, ma. 1/2. Specific heat of ice is 1/2, no? So 10. So 10 calories of heat energy I am supplying. So if I supply 10 calories, first 1 gram of ice, 1 gram only I have given, 1 gram means your answers may be correct. I thought it is 10 grams. Okay, ma. So 1 gram ice converts into 1 gram of ice only. But temperatures are changing. Now if I continue heating, I am supplying Q2 heat energy. Then what happens? 1 gram of ice, this is the temperature where ice melts, no, ma? So it converts into what? It converts into 1 gram of water. But what is the temperature? Temperature will not change, no, immediately. It remains to be 0. Because when state is changing, temperature does not change. Okay? But what is the heat energy I have to supply, ma? Q2 is equal to M into L. This is the formula I have to use, no? Mass is 1, latent heat is 80. So how much? 80 calories of heat energy I have to supply in second stage. Then if I continue heating this water, what happens? Again it converts into water only. But at what temperature, ma? At 100 degree Celsius. So here the heat energy supplied is Q3. So Q3 formula? ML delta T, MS delta T or ML? MS delta T. Why MS delta T? Temperature is changing, no? So I will write MS delta T. So mass is 1, specific heat is 1, and the change in temperature is 100. Okay, ma? So 100 calories of energy I have to supply. Okay. Now if I continue this heating this water, okay, ma? Then what happens? Now this water converts into steam. And what is the temperature of steam? Temperature of steam is 100 degrees Celsius. Energy supplied is Q4. So Q4 MS delta T or ML? ML, because temperature is not changing, no, mass, state is changing. So mass is 1, L value is 540. So total how much? 540 calories of heat energy I have to supply. Then again if I start heating this steam, then steam remains to be at steam only, but it is Q5 and the temperature is how much, ma? 120. So again which formula? Q5 is equal to MS delta T. Mass is 1, specific heat is 1, change in temperature is 20. So 20 calories of heat energy. That's all, no? So this is the total energy I have to supply. Okay. Then finally minus 20 grams of ice, it converts into steam at 120 degrees Celsius. So what is the total amount of heat energy? It is Q1 plus Q2 plus Q3 plus Q4 plus Q5. Clear, no? So Q1 value 10. 10 plus 80 plus 100 plus 540 plus 20. Did you calculate? 7, no? 750 calories of heat energy. Okay, ma? ఇది తప్పు అయితే చెప్పిన వాళ్ళని ఉతికి పారేసేయండి. నాకు మాత్రం తెలియదు 750 వేసేస్తాను, అది విషయం. ఓకే ఓకే మా. సో లెట్ us see this question, ma. So when 20 grams of water at 50 degrees Celsius is mixed with ice, ma, and what is the mass of ice? 50 grams ice. And what is the temperature of ice, ma? Minus 30 degrees Celsius. Then if you are mixing both of them, what is the final temperature of the mixture? Okay. So here we will first of all write one very important concept, no? A concept that you know your common sense can understand it, but still it is called as principle of calorimetry. Principle of calorimetry. Okay, ma? Principle of calorimetry says that heat lost by a substance is equal to heat gained by another substance. Okay, ma? This is called as principle of calorimetry. Okay. Which body loses heat energy, ma? The body which is at higher temperature, it loses energy. And which body gains heat energy? The body which is at a lower temperature, it gains energy. So what is the energy lost by hotter body? Same amount of energy will be received by cooler body also. That is called as principle of calorimetry. Understood, no? Now this problem also we have to solve it by using principle of calorimetry only. Okay. Now what are the two mixtures we are mixing, ma? We are taking water at what temperature? At 50 degrees Celsius. And what is the mass of water? 20 grams of water. And I am adding this one to what? I am adding this one to ice. At what temperature? Minus 30 degrees Celsius. Okay, ma? And how much mass is present, ma? 50 grams of ice was present. So which one loses heat energy? Which one gains heat energy, ma? Water loses heat energy because it is at a higher temperature, no? And ice receives heat energy because it is at a lower temperature. Understood, no? Now when we mix both of them, what is the final temperature of the mixture? That I have to calculate. Are you able to understand? So in this type of conditions, okay, ma, we can do this problem by one method. First of all, I have to see water can supply how much energy. Is it necessary to melt all the ice or not? First I have to check that point. Water can supply how much energy? And is it necessary, is it enough to melt all the ice or not? If it is able to melt all the ice, then remaining energy will be used to raise the temperature of that melted water. Okay, ma? If complete ice is not melting, then temperature doesn't change. Are you able to understand? So first of all, that information we have to see. So what is the note point I have to write, ma? Note point is that first we see if water can melt ice completely. Okay, ma? First of all, we have to see whether ice can melt the water completely or not. Understood, no? So to reach 0 degrees Celsius, water can lose how much energy, ma? It can lose Q is equal to ms delta T energy. Are you able to understand? What is the temperature of water? 50. So if water goes to 0 degrees, then it is losing heat energy, no? So when water is cooling down, is it losing energy or gaining energy? Losing energy. How much energy it can lose? Q is equal to ms delta T. Temperature is changing, no? So ms delta T. Mass is how much? 20 grams. Specific heat of water? 1. Change in temperature? 50. So how much energy it can supply, ma? 1000 calories of heat energy water can supply. To reach which temperature? To reach 0 degree temperature, water can supply this much amount of energy. Now let us calculate energy required for ice to melt, or energy required Okay, first of all we will do one thing. Energy required for ice to come to, or to cool, or to reach, that is better, to reach 0 degrees Celsius. Okay, ma? So what is the temperature of ice, ma? Minus 30. So this ice, first of all, it should come to 0, no? First of all, it should come to 0. So to reach 0, let us see how much energy it can, it requires. So that is again ms delta T only, no, ma? Clear, no? So mass of ice is how much? 50 grams. Specific heat of ice is 1/2. And what is the change in temperature? From minus 30, it should reach 0. So change in temperature is 30. So 2 1s are 2 15s are. So 15 5s are 750. So 750 calories of energy it requires. Are you able to understand? Is it clear, ma, what is happening? So water can supply 1000 calories. But ice, to reach from minus 30 to 0, it requires how much energy? 750 calories. Ice, has it melted, ma? No, ice did not melt still. Are you able to understand? Just for ice to reach from 0 to, minus 30 to 0, it requires this much energy. Then what is the energy required for melting? Energy required for melting. For melting, which is the formula? ml. So Q is equal to ml. Mass is how much ice? 50. Latent heat of fusion? 80. 8 5s are 40. 4000 calories is required. Okay, ma? But water can supply how much energy? Only 1000. But ice requires how much energy? It requires 750 plus 4000. Then ice can melt completely. Are you able to understand, ma? Sequence of steps. The supplied energy is how much? Required energy is how much? These two always you should compare. Without comparison, you cannot do this calculation. Okay? So pure common sense, intelligence, reactiveness, responsiveness, sensitiveness should be required for solving this problem. Clear, ma? Now see. Water can supply 1000 calories. Okay? And for ice to reach to 0, it requires 750. It means total ice can reach to 0, no? Total ice can reach from minus 30 to 0 because it requires only 750. But water can supply 1000. So out of 1000, 750 is utilized, no? Now remaining is how much? 250. What about this 250? What this 250 will do? Now this 250 will start melting the ice at 0. Clear, ma? So for ice to reach from minus 30 to 0, it requires 750. Now total ice at minus 30, it has reached to ice only at 0. Are you able to understand? Minus 30 ice converted to 0 ice. Ice only still it has not melted. Now what is my product I have? Ice. At which temperature? 0. For that one, out of 1000, how much energy is utilized? 750. Now what is the extra energy water has? 250. That 250 is utilized for what? For melting the ice. Is it clear? That's all. Write the statement of that. Okay, ma? So therefore, completed, ma, this one? Therefore what we write? So total ice at minus 30 degrees converts into ice at 0 degrees Celsius. And it requires how much energy? 750 calories of energy. Okay, ma? Therefore, energy left with water. Energy left with water is how much? 1000 minus 750. So how much? 250 calories. Okay, ma? This 250 calories is used for melting ice. Okay, ma? And so listen, ma, from here listen. From 250, how much ice can melt? That I don't know, no, I have to calculate. So melting means temperature will not change, number. So which formula I have to use? Q is equal to ml. So supplied energy is how much? 250 is the extra energy which I have. Mass of ice melted, I don't know. But latent heat of fusion is how much? 8. So mass is equals to 25 by 8 grams. Clear, number? So out of total, how much ice? 30 grams of ice, 20 grams of ice. Out of 20 grams of ice, this much of ice will melt. 50 grams. So out of total 50 grams of ice, only this much of ice will melt. After melting, what is its temperature? 0 only. Melt అయినప్పుడు temperature మారుతుందా? మారదు. So temperature remains to be 0. What is the temperature of unmelted ice? Unmelted ice, 0 only. What is the temperature of water after reaching to 0? Enta? 0 only. So temperature of everything is 0. Temperature of final mixture also 0. That's it. ఏమన్నా అర్థమైంది? Clear, number? So what are the 3 final products I have? Water reached from 50 to 0. So temperature of water 0. Total ice converted from minus 30 to 0. So temperature of ice 0. Some ice melted, no? Even after melting, what is its temperature? 0. So what is the temperature of total mixture? That is my answer. Understood, number? So temperature of total mixture remains to be at 0 only. That is my final answer. Understood, number? So right. So therefore what we write? We write temperature of all contents. Temperature of all contents is 0 degrees Celsius. That is our answer. Understood, no? So this is the method of solving these problems comparatively. Okay, ma? Check the required energy you require and check the amount that is supplied. Okay, ma? Supplied energy, required energy. You have to compare them. Then you will reach to some point. Okay? That is how you have to do the calculation.